Good morning, good afternoon. Thanks for joining us and welcome to this webinar called Step by Step, the Higg FEM Verification Trail section for water use. We from Leadership and Sustainability are looking forward to spending the next hour with you. This is the third in a series of webinars where we will take you into depth of the different sections of the Higg FEM, the Facility Environmental Module. My name is Karen Ekberg, and I'm the founder and manager of the consulting company Leadership and Sustainability. I have spent nearly 35 years in the sustainability area. I have worked in many different sectors, but during the past 11 years, I have worked in the textile sector. Before I started my own company, I worked several years at Adidas in the role of Head of Environmental Services, and I was responsible for environment globally. This role included developing the environmental strategy for the supply chain. So let's begin. We will introduce you to the SAC Higg FEM Facility Environmental Module, continuing with the Section 4 water use today. And after you have gained an insight into the section, we will also make a few examples followed by your questions and discussion. And finally, we will make you an offer and present our team to you. So let me introduce you to the verification trail. The purpose of the verification trail is to give you a better and deeper understanding of the Higg FEM. We will take you through the Higg FEM section by section and make you acquainted with all requirements. We held the first webinar in September about site info and permits and continued with section and also environmental management systems, and we continued with section 3 energy and greenhouse gas end of October. And today we will follow through with the water section. Before we continue on our trail, I would like to give you an overview of the verification process. If you want to go from your self-assessment to also be verified, we have identified 7 simple process steps. First of all, you complete the self-assessment. This is where our webinar series is striving to support you in. And here you will be using supporting documents such as, for example, the How to Higg guidance. And then you will engage your verifier and provide a lot of information about your facility. And then you make the self-assessment available to the verifier. The verifier reviews your self-assessment and your documents and informs you also about any issues before the actual verification. We have an agenda sent to you, and then also during the on-site visit or potentially also during the off-site verification, we will go through all documents and all your responses and verify them. And finally, there will be a reporting meeting, and you will be able to post your results on the higg.org. And SAC has issued a protocol for on-site verification, which gives information about the verification process, but it is actually also possible to do an off-site verification. For all of you who are doing your self-assessment or preparing to get verified, here is some very important advice. First of all, you need to appoint a person who is responsible. So it needs to be someone who has the oversight of the entire Higg FEM self-assessment and verification. And even this person may need to collect information from other colleagues in the factory, but it is really good to have one person who coordinates everything. And then there is a very long document, the How to Higg document, but it is also very valuable. It contains a lot of information that you need to know about how to understand the different questions, but also what is needed in order to get a full score in the assessment. And then there is also a verification preparation guidance for facilities. And then you respond accurately to all questions, comprehensively, and you also document all responses. SAC requires documentation proof for nearly all questions. The SAC guidance on how to verify, the How to Higg guidance, is very strict regarding documentation. So please make yourself prepared and collect all your documentation and keep them also on your own file. You can upload the documentation on the Higg.org platform, but from time to time we have been experiencing problems with downloading the documents later. So it's good if you have them on a file, also for verifiers, the day you want to be verified. Then be clear when setting targets and baselines. Baselines, you need to define them well. They should also be stable. And we will talk much more about both targets and baselines later in our call today. Then also be aware of the time needed. If you need to collect information from colleagues, collect data, etc., it may take some time to do that. So you may need even a few weeks to complete the self-assessment. And then, of course, the ultimate goal is to improve every year, to have a continuous improvement cycle in your factory. And so now let's have a look again at the verification trail. Here you can see an overview of all the sections that are included in the FEM model. And today we will speak about water use. So let's have a look at this section. Fresh water has always been a scarce resource for our planet, as 97.5% of all water is seawater or brackish water. And even 75% of that 2.5% fresh water is tied up in glaciers, making only 0.6% of all water available for use. And here you can see a map from the United Nations Environmental Programme. It shows the percentage of all available water that is actually used for 1995 and for 2025. And you can see the dark orange means that more than 40% of the available water is actually also used. And the lighter orange means that 40 to 20% of the total available water is used. And you can see when you go from left to right from 1995 to 2025, you can see that the map is the yellow or light orange and the darker orange colors, they are increasing. So there are some countries where today in 2025, the estimate is that there will be more than 40% withdrawal of total available water. So the water scarcity is increasing year by year. And there is a question in the Higg FEM where you should also evaluate your water risk. And in order to do so, the Higg FEM asks you to use one of the two tools that you can see here, the WRI, the World Resources Institute, and their aqueduct tool, or the Worldwide Fund for Nature and their water risk filter. And on the map here, you see an extract from the WRI aqueduct tool. And you can see that, for example, the dark red means that there is an extremely high risk for water, an extremely high water risk. And a bit lighter red means a high risk, etc. And you can go and find your own location in this map and easily find in which area you are. You need to be quite detailed, so you need to give the coordinates or the actual specific location where you are used, since the regions may, the colors in the regions may look as if everything is red, for example, but if you go into detail, it may actually be dark red. So this is one of the applicability questions, and depending on your water risk, you will get slightly different questions in the Higg FEM. There will be more questions if your facility is located in a high risk area. And since every section consists of 3 levels that you can reach during your assessment, we will guide you now through the 3 water levels. For each level, there are allocated subtopics with corresponding questions. And in the water section, you can see there is only one question at level 1, and then we have several questions at level 2, and we have also one question at level 3. And remember, the score allocation is as follows. At level 1, you have 25 scores. At level 2, 50. And at level 3, another 25. So in total, 100. But now let's go to the detailed questions. The first requirement deals with the selection of all sources of water use for your facility with corresponding questions according to your water sources. Does your facility track its water use from this source? What quantity of water was used by this source in 2018, if you are completing the self-assessment right now? Which method was used to track this water source? What was the frequency of the measurement? And then you can also provide any additional comments. And the intention of the first level is that the measurement of all freshwater use from all freshwater sources is the foundation of a good water management. It helps you to perform a water balance and set freshwater key performance indicators, identify water leaks, and establish and measure your freshwater footprint. So if you will receive full points if you are completely tracking all sources of water that your facility uses, and you will receive partial points if you are completely tracking at least one of your water sources, but are not yet tracking all of your water sources. And the question 2 is, has your facility set baselines for water use? And here the intent. It is important to know what your starting point is. Therefore, a baseline provides you with an overview and a clear reference point for ongoing water performance tracking and target setting. So of course, if you want to improve your and reduce your water consumption, you need to know from where you are starting. And that's the purpose of setting the baseline. And also during the verification, we will ask you to explain how your baseline was calculated. Was it absolute or normalized? We will also have a look at the unit of measure, and we will check this. So currently in the Higg.org platform, the drop-down list contains unit of measures only for absolute baselines, unfortunately. But you can still add normalized values and describe how the baseline was calculated. So let's have a look at water baselines. So when it's time for the baseline, it's really important for water use management. There are two types of baselines, absolute and normalized. Absolute is very simple. Absolute is just the total consumption. For example, you used 10,000 cubic meter of fresh water in 2018. So if you decide that your baseline would be in 2018 and you want to use the absolute numbers, your baseline would be 10,000 cubic meter. But normalized baselines, they also consider the actual production that you have. And since you may have water in use in your processes, so if you have wet processes, then you will consume water not only in the domestic region with toilets, etc., but you will probably use more water in your actual manufacturing. And then, of course, the water consumption will be dependent on how much you produce of your products. So, so normalized baseline is more effective to use as a reference if you have manufacturing that increases or decreases year by year. Sometimes you may be utilizing 100% of your manufacturing capacity. Other years you may be utilizing only 80% of your manufacturing capacity. And then obviously you will use less water, but also produce less products. And that's where the normalized baselines then are a help. And it may also be that you produce very different products. So of course, if you have been producing several different products and now you begin to produce much more of products that use more water per product produced, so to say, then of course also your water consumption will go up. And so if you just take an average normalized value, you will not cater for this. So there you may even need to divide and calculate KPIs for your different products or different styles that you have. But this may be very complicated. So let's see how you can calculate a simple water baseline. So let's say that we have a total water consumption of 40,000 cubic meter, and with that we produced 1 million pair of jeans. And now we divide the total water consumption with the total production volume. And this gives us 0.04 cubic meter per pair of jeans, which is the same as 40 liter per pair. So we take 40,000, which is the total water consumption, and we divide it with 1 million, which is the number of pieces, the pair of jeans that we produce, and the result is 0.04 cubic meter per piece. In this case, we were using not only municipal water, we were using also well water. And for each of them, we were using 20,000 cubic meter. So for the total baseline, we have 0.04. If we want to calculate the baseline also for the municipal water, then it's 0.02. It's the 20,000 divided by 1 million. And for the well water, it's the same, then 0.02. And then this baseline is now the baseline that you will be using moving forward, perhaps for a few years until you take a new baseline. And the next level, next question, sorry, at level 2 is question 3. Does your facility know what facility processes or operations use the most water? And the intent here is that for sustainability efforts, a facility should identify and rank water impact influences within the facility boundary. This enables an understanding of specific influences on water impact so that the facility can strategically reduce the water usage and impact by targeting those processes. So if you know which of the processes where you're using most water, you should try to reuse there so that you can have the greatest impact when you set your targets. So a first step would be to map out your production processes together with, for instance, a site process flow diagram with identification of where usage is metered or can be estimated. And this involves to manually list out all equipment on site that uses water, and then identifying, for example, through meters or other estimates, how much water each item on the list uses. The question 4 is about water targets. Has your facility set targets for reducing water use? And if yes, select all sources of water for which your facility has set a reduction target. And here, in order to get a full score, you need to target more than 80% of your consumption when setting goals. And you will receive partial points if you set targets for water sources that make up 50 to 79% of your total water use. So please see if you can set target for more than 80% or for 80% or more. And here now is a simple decision tree that can help you evaluate your water saving opportunities. So you can use this flow diagram as a guide and basically ask all of those questions in relation to your water savings opportunities. So you begin at the top, you have the source of water, and you ask yourself, can water use be eliminated at this source? Perhaps it can, then you can implement a program accordingly. But you can also move forward to the next question. Can the amount of water used be reduced in some way? And can water or wastewater be reused or recycled? And then, of course, you need also, in any case, to ensure proper management practices, that they are in place also for wastewater disposal and discharge. So those are several questions that you can ask yourself, and you can ask yourself those questions at each and every process in your facility that uses water. And then when it comes to setting the formal targets, the formal target should include a baseline performance value, the targeted reduction, for example, 5% reduction per piece, expected completion date, And it should also be relevant to the site's most significant sources for water use. And here now, this is quite a detailed table here, but this is just an example of 2 targets. And they may not be applicable to you, but it's just as an example. So in the first case, the target is to reduce production water use per square meter of fabric produced by 15% in 2018 compared to 2016. And then the action in this case would be to install countercurrent water recycling system for washing water, and the expected water reduction 15%, which in this case would mean also a reduction of 15,000 cubic meter per year. And this installation would cost $15,000, and the completion date is October 2020, and we also have someone responsible for that. So this is also an example of how you can build out your action plan when you set a target. And then when the next question is actually about the action plan or the improvement plan, and the question is, does your facility have an implementation plan to improve water use? And you can answer yes if you have an implementation plan in place that demonstrates that you are taking action to achieve your targeted reductions. And answer partially yes if you have a plan but have not started on all action items that should have been started. And when we are verifying, we often see that there is a lack of complete improvement plans. So you may set a target, but there are no actions behind it. But of course, if you don't have a very detailed implementation plan, it will be difficult for you to follow through, and it will be difficult for you to reach your goal and your target, because you need to define the actions in order to get there. It will not happen just by itself. And the intent of the action of the question is really that an action plan supports you with target setting and is an important step in managing your water use and to take reductions. And here we also have an example of such an implementation plan. This is something you can use not only for water, but actually for any action, any target that you have. And the link is available here as well. This table comes from the How to Higg guide. And then when it comes to potential for improvements, improving production efficiency, if you increase your efficiency, you can produce more at the same time and with the same consumption of water. So there are several different types of actions that you can take. You can improve production efficiency. You can modernize compressors, for example, or other equipments. You can upgrade machines. You can use more sustainable chemicals that eliminate some of the steps perhaps, or reduce the water consumption, or works, for example, at a low temperature, and so are using less resources, even if a lower temperature, of course, would not reduce the actual water consumption. You could also try using rainwater, and then or zero liquid discharge, for example, that you can recycle some of the wastewater or all of the wastewater into the plant again, and therefore reduce the use of fresh water. And there are also a lot of different projects related to water management, and some of them we have listed here. One is the STWI, Sweden Textile Water Initiative. Another one is PACT, the Partnership for Cleaner Textile. And then we also have the Clean by Design, originally started by NRDC. So those are some actions that you can take, and also some programs. There are many other projects and programs around water management, but these are just a few examples. And then the next question at level 2, that's question 6 about demonstrated improvements. Has your facility reduced with water withdrawal compared with your baseline? And then you should select all water sources that have been reduced. And here again, You will receive full points if you have reduced water withdrawal with at least 80% of your total water volume, similar to how you set the targets then. And here we will, during the verification, we will ask to see all the items and also see how you have calculated. It's a good idea to keep all reports, all quantitative data in Excel year by year, and keep them. You could keep the same Excel table, use several different tabs. And you can also see here an example of what it would look like in the tool online. And then finally, at level 3, and we have the one question at level 3, the question 7. Has your facility implemented a water balance or another analysis to evaluate the traceability of water intake versus usage? For example, which processes and also output, for example, to wastewater treatment plant. And the creation of a full facility water balance provides insight into areas with efficiency improvement opportunities and allows facilities also to identify water that may have not been recorded for. And it includes, for example, the incoming water in the facility, amount and water sources, the quantity of water used during the production processes, the quantity of water recycled or reused in the facility, the quality of the wastewater that is generated, the wastewater generated in the facility, the volume of water discharge after the own treatment, and also the frequency of which the water balance is updated. And we have an example for you here. Here you can see one from a wet process facility. And if we go from the top, you can see the raw water, the fresh water that is coming in is here 135 cubic meter per day probably. And it is divided into 5 cubic meter that goes into the sanitary area, and 35 that goes into the actual manufacturing processes. And here in this case, actually 95 goes to the boilers, quite a lot goes to the boiler. And then you can see how the water flows through the plant. We actually here, we also have some recycling. So you can see that after the tertiary wastewater treatment, the third step in the wastewater treatment, we have recycling of 25 cubic meter per day that goes in here. So totally, actually, that what goes into the process here is actually 60 cubic meter per day, but only 35 cubic meter fresh water, etc. And then you can see how what it looks like here throughout the balance. So this is what is expected when you develop a water balance. And I would also, and here you have flow meters, monthly tracking, and the difference, etc., how you can develop this water balance. Now, I would like to give you some examples that may be relevant for your facility's water consumption. I would like to show you a water use breakdown, and after that, we have some best practice examples from the Natural Resources Defense Council, NRDC, and their report on water best practices for textile mills. And here is one example. This might not be true for your facility, but this is just one example of how the water distribution can be done in the different parts of the factory. So it shows here, for example, bleaching uses 38% of the fresh water, dyeing 16%, boiler 14%, printing 8%, and then there are some other uses as well. So this is an example of what it could look like. And now, very detailed chart here with a lot of detailed examples. The NRDC conducted 5 expert efficiency assessments of real-world manufacturing practices and identified incentives that would immediately make typical production processes more efficient and deliver substantial environmental improvement at the same time. To minimize losses and achieve the best practices demonstrated in this table here, specific engineering improvements to factory infrastructure may be required. So those may not be so easy to implement, but they may need some installations, and it may cost also something to do this. But for example, wet processing like pre-treatment, dyeing and finishing typically accounts for a significant portion of water consumption and wastewater discharge. And recycling and reuse measures that focus on these processes yield great savings. And since the water recovery is often hot, for example, these improvements may save energy as well. According to NRDC, a mill that implemented all of the water best practices suggested would save between 27 and 37 tons of water per ton of production, 13 to 24% of its total water use. So just to pick a few of those examples that you see listed here, leak detection, preventative maintenance, improved housekeeping. Although individual leaks may not seem important in the overall consumption picture, they can be responsible for a surprisingly significant loss of resources over the course of a year. And you see here the example of being able to save 0.6 to 3.1 ton water per ton fabric, which would mean 1 to 5% of savings in total. And then we have several categories of reusing cooling water. And here you have the potential percentage savings of 2 to 9%. And there are several other examples here, as you can see. And here is the link also to this report. And take a look at that report. It's really a very good resource also for energy savings, not only for water savings. And that was actually our presentation for today. So now I would like to open up for questions. And let's have a look if we already have a few questions that have come in. Otherwise, please feel free to send us your questions. Yes, I have one question here. What is the accepted difference of extracted and discharged water? So the question is about potential losses that you may have in your facility. And I think this depends really very much on the type of manufacturing that you have. You may have, for example, with your boilers, you are evaporating water, you may be losing water there. You may have other processes with where you have evaporation of water and you will be losing water. So, I mean, in general, the difference should be very small. But as I said, if you have processes where you have a lot of evaporation, you may actually be losing a significant portion or a portion of your of the total extracted incoming water. And then, is it mandatory to be engaged with a water project? No, it is not. It is really up to you. And also, just to be clear, everything in the Higg FEM is voluntary. It's up to you to decide if you would like to if you would like to move forward, and which questions you would like to reply to and to improve on. And of course, how you do that, that's also up to you. Of course, you may have buyers, you may have brands who are asking you to make improvements. And then according to your business relationship with them, you will also want to improve. But it is not mandatory to be engaged with a specific project. You may have buyers or brands who ask you if you would be interested in participating, for example, in the Swedish Textile Water Initiative or in the Clean by Design project, and then you may be interested in doing that. Most of the time, actually, those programs are really quite valuable, and we see that many facilities are also able to save money based on the participation in such programs. And then we have here also one question. Could we break down the water use into different buildings and not only by operation? Yes, of course you can do that. And it may well be that you have meters installed so that you actually can, that you know which water flows you have into the different buildings. So for sure you can do that. And it's really a matter of you looking at the entire water use that you have, in which processes, in which buildings, and then decide where does it make most sense for me to try to save water. And you can also, of course, try to save water also with the domestic use that you have. By faucets that where the water flow is slower, for example, or in the toilets, and also by just awareness raising and training with the facilities to support them in understanding to use on how to use less water. And here, one really good question also about the normalization. So why is the water target based on total number of pieces produced? Why not based on number of employees? For example, for a cut and sew facility where you don't have that much, you don't have any wet processes, but the entire water consumption that you have is actually for domestic use. And in this case, it may makes much more sense to have the normalized value by number of employees, since it's only the production doesn't influence your water production, but only the number of employees that you have influence the water consumption that you have. So that's a good question. And this is also something that needs to be clarified. So we say that often a normalized value is better, but it is also not so easy to find and calculate the right KPI. And you as a factory, you need to evaluate what is the best KPI for our purpose. For a knit composite RMG, is it appropriate to calculate target based on dyeing production? Yes, it may be. Yeah. So basically, if you look at the processes where you consume the most water and what type of processes they are they influenced by production, or what are they influenced? And then you basically have to decide which is the best KPI for me to use. And then we have a question here. If a facility set a target for the next years as decreasing water use 5%, but in the next year they achieve only 3%, will the facility get the point or not? Yes, you will get points if you have reduced your water consumption. The tool currently does not compare with your actual target. And also you said that you set a target for the next years. So if you set a target for 5% by, for example, 2022, and in 2020 you achieve 3%, then you are still working towards your 5% goal. But the tool, when they calculate the scores, they only look at if you have actually improved, reduced your water consumption, but they don't compare with your target. One more question. If the facility is a washing garments factory, then which procedure we should use to show water ranking? Well, it is the same approach as in any factory. Look at where you are using, in which processes you are using the most water, and then accordingly you make that water ranking. And it may also be that you would need to install meters or make estimations. Sometimes you can make estimations based on the equipment that you have installed. So for example, washing machines, they have information about how much water they use per cycle, for example. So that could be also, instead of just metering or measuring, you could use the information that you have from the equipment provider. Regarding the difference between intake and versus uses deviation, No, there is no numerical value that I can give you. I think that there are available numbers in the literature depending on which type of factory, but I don't have any numbers right now for you. And then we have also one question. If two factories are located in a compound and they are using the same water tank, how can we then calculate the individual facility quantity? Well, you actually cannot do that. So let's say you have both factories are withdrawing water from this water tank, from the same water tank, then and you don't have any meters installed at the inlet of your factory, then it's not possible to calculate it. So you would need to install a meter there. And then a general question here about how to be efficient in washing process. Any special method or process that needs to be implemented? There are lots of things you can do. You can talk to the machine manufacturers. If you are able to replace machines, for example, and use washing machines, then that use less water. But also, as I mentioned, this NRDC document is a really very good document. And also the programs that I talked about on their websites, you can also find a lot of tips about how to save water in the washing process. All right. I think those were all questions at the moment. Okay. No, we have one more here. How to calculate the percentage of fresh water consumption, recycled water consumption against production? Well, here you need meters here. You need to have all the meters. And then if you have the numbers for those different streams, you can calculate the percentage by dividing. So for example, you have the total freshwater consumption, and then you have a certain, let's say 100 cubic meter, you recycle 25 cubic meter, then the percentage of recycled water is 25 of the total fresh water. But you need to take your own numbers, of course. And then one more question, are there any benchmarking ideas or tools or other achievements data? Well, as I said, I would suggest going to that NRDC document or also to one of the programs that we listed. The Clean by Design is the NRDC, but also the Swedish Textile Water Initiative and the PACT initiative. They have a lot of information as well on their websites. All right, so great. So thank you so much for all those questions. And let us move back to the actual presentation. And I just have some more information for you. So here you can see where we have training and verification. We do not have local people everywhere in all those countries, obviously. But as far as possible, we are able to conduct verifications and have conducted verifications in many of those countries. We have several languages among our verifiers. So you can see the list here to the right. And so we would be happy to support you with a verification. And also, of course, now it's running towards the end of the year. If you haven't planned for your verification yet, you don't have that much time left. But for next year's cycle, plan please for the verification early enough. We have seen that there are a lot of factories who want to do the verification towards the end of the year. And also you need also to be aware that you cannot always buy the VFEMs that you need in order to do the verification. You cannot always buy them until just the end of the year. So for example, that portal to buy VFEMs have already been closed down by Higg FEM. So those are also things that you need to take into account. And of course, the earlier you do the verification, the longer you can use those results also with your clients and with your buyers. And then if you are interested in hearing more about the different sections that we have done so far, then please go and listen to the webinars that we have been holding, so about energy and greenhouse gas, and also about the site info and permits. And we have also one webinar that takes you through the entire Higg FEM verification process. And we have also another webinar on how to improve your SAC Higg FEM score. So there are several webinars available to you. And we will, of course, continue in the next year with the next sections in the Higg FEM. So please have a look out for the next announcements about our webinars. And so we invite you to do training and verification with us. You are really welcome. We also can help you improve. If you wish to improve your scores or wish to improve your performance overall, we are happy to support you with that. So please, if you are interested, contact us. You can book a time with me directly online by clicking on this booking page link here. Or you can also contact us directly. So at the bottom here, you can see a link to my email address. In Turkey, you can contact Aladdin Okur. And in Bangladesh, you can contact Hafizur Rahman. And so we have come to our final slides. And here you can see our team, our growing team, happy to say. And then thank you so much for joining us today. And goodbye, everyone.